So when you're splitting the data set, say you're splitting into the training and testing set, you have conflicting priorities. On one side, you would like your estimate of the future error to be as reliable as possible. And we talked about the estimate of the future error directly depends, the confidence interval directly depends on the number of instances in the test set. So you want to make the test set as big as possible, because then you'll be confident that your estimate of the error will actually carry over into the future. So you want a large testing set. On the other hand, you want to build an accurate classifier, and you want your classifier to be as accurate as possible. And the accuracy of a classifier will be higher if you give it more data. So the more data you give it, the better it will learn. So you would like your training set to be as large as possible. And unfortunately, it's a zero-sum game. You only have so many labeled instances. So the sum of the sizes of the training and the testing set is a constant. That's limited by how much data you have. So you want to make this one as big as possible, but that will make the testing set smaller. Or if you make the testing set very, very large, that'll make the training set smaller. So there is, however, a way to have your cake and eat it too, and that is to use cross-validation. And the idea of the cross-validation is you use the same data twice, in a way. Right? So first, you split it up into training and testing. You use the training to build a classifier, and you estimate the performance on the other half, on the test set, and then you flip the sets around. You build a classifier on the testing portion, just on the testing portion, and then you run it on the training instances and compute the error on the training instances. And then you average the error that you got in the first fold and in the second fold. Now, why is this legal to do? Am I not overlapping the data? You're not, because in each fold, at each step, you're using each instance only in one way. So in the first step, any instance in the training set, it's used for training classifier. It's not used for computing the error rate. In the second fold, that same instance will be used in an opposite way. You will not be using it for training. You will use it only for computing the error rate. So in this way, what you get is you effectively use every instance in your corpus as a testing instance. You just don't use them all at the same time. So in general, you don't do it with two splits. You take a data set and you cut it up into a number of parts. So here's an example of what's called a 5-fold cross-validation. So I take my data set, I split it into 5 parts. I use part 1 as a testing set and parts 2 through 5 as a training set. So this means that I'm using a lot of the instances to train a classifier, 80%, and I'm using 20% to test the classifier. But then I'm going to repeat it 5 times. And by the end of it, I will have used every single slice as a testing portion. So eventually, I will have used all my instances as a testing set, just not at the same time. Okay, so good question. So what is your final classifier? In the process of doing this, you will build 5 completely different classifiers, and you will test them 5 times. So computing the error rate is not a problem. You just take the average. But you cannot take the average of the 5 classifiers. What you typically do in this case is you take, at the end of doing the cross-validation, you take all of the data points, put them all together, and train a classifier from 100% of the data. You cannot compute an estimate for the accuracy of that classifier because you have no data points left. But you can build a classifier from everything. And typically, its error rate is going to be no higher than the error rate that you estimated through cross-validation. So that's the answer. Your final classifier is the 6th classifier that is built from all of the instances. And you cannot test it on anything because you have no data left. Only the data that comes tomorrow. So the question is 5 folds. This is just for estimating the error rate. It's for doing two things. It's for estimating the future error rate. It can also be used for selecting the meta parameters of the classifier. So you build a decision tree, you build a naive Bayes classifier, you run both of them through a 5-fold cross-validation, you estimate the average cross-validation error for the decision tree for naive Bayes, and then you decide, okay, it looks like decision trees are going to work better. So you decide to use a decision tree, you merge all the data into one big training set, train up your decision tree, and hope for the best tomorrow. Okay, so that's a 5-fold cross-validation. Typically, more common is a 10-fold, which is very similar. You're just splitting it up into 10 different slices.